Alright, students, in this video, I'll be going through the 2013 O-Level Paper 2 question 8A. Okay, so the question goes like this. Without using a calculator, find the fractions A and B for which square root 6 plus square root 5 over square root 15 minus square root 2 can be expressed as A square root 10 plus B square root 3. Okay, so this is actually a rather direct search question. Okay, so let's get started. Okay, so the search that we are given is square root 6 plus square root 5 over square root 15 minus square root 2. Okay, so when dealing with a third question, so the first thing you must ask yourself, can any of these four thirds, right, be simplified? Okay, so you can see, you should be able to tell that none of them can be simplified, okay? Okay, so for thirds, basically, you just need to pay attention to two things. Simplifying thirds, and the second one is to rationalize the third. So since there are no thirds that we can simplify over here, that means what we need to do to simplify this expression would be to rationalize it. Okay, so we can rationalize it very easily by multiplying by the conjugate of the denominator. Okay, so we'll multiply by square root 15 plus square root 2. Then remember, if we multiply by square root 15 plus square root 2 below, we need to do the same on top, right? Okay, so for the top, we're just going to use the rainbow method to expand it, to multiply it together. So square root 6 times square root 15 will be square root 90. Okay, then be careful, do it step by step. Square root 6 plus times square root 2 is square root 12. Okay, then plus square root 5 times square root 15 will be square root 75. Then square root 5 times square root 2 plus square root 10. Right, then for the bottom, we are going to make use of this special product, right? A minus B times A plus B equals to A squared minus B squared. And this is precisely the purpose why we want to multiply by the conjugate. Because if we multiply by conjugate, we'll end up squaring both A and B, and that would remove the surds and hence rationalize the denominator. Okay, so over here will be square root 15 squared minus square root 2 squared, right? Okay, then for the top over here, you see in the final expression, right, we want square root 10 and square root 3. So this means that we need to simplify the surds on top. Okay, now that the numbers are very big, there's a likelihood that we can simplify. Okay, so for example, like 90, we can split it into 9 times 10. So that's where the square root 10 is going to come out from. Okay, then for 12, we'll split into 4 times 3. Then that's where the square root 3 will come out from. Okay, then for 75, we'll go for 25 times 3. Okay, then square root 10, we can't simplify. Okay, so just leave it as square root 10. Okay, the bottom will just be left with 15 minus 2. Okay, so the top, square root 9 will be 3, so 3 square root 10. Square root 4 is 2, so 2 root 3. Square root 25 is 5 root 3. Okay, then this will be square root 10 over 13. Right, so we're almost done. Okay, so from here, okay, sorry, okay, so let's group the sets together. So 3 square root 10 plus square root 10 will give us 4 square root 10 plus 2 root 3 plus 5 root 3 will give us 7 root 3 over 13. Okay, so we are going to express it in the form a root 10. So we'll have 4 over 13 root 10. So that means a is going to be 4 over 13 plus b is going to be 7 over 13 root 3. Right? Okay, so this is the way that we're going to handle a question like this. Right, so from here, we can say that a equals to 4 over 13 and b equals to 7 over 13. Right, so remember for surds, two things you need to know: how to simplify surds, how to rationalize surds. Right?